So guys, we are continuing with automating the boring stuff with Python. This book is available for free. If you head over to automatetheboringstuff.com, you can see and find the entire book in the current version. We will continue with Python basics in chapter 1. So let's dive right in. And in the previous video, if you didn't see it, we actually had a look at how we can set up Python, how we can install it, and also how we can install a code editor. We are using Mu as our code editor, and we can open it up. Here's the code editor. Last time we had a quick look at how we can use the REPL, our interactive shell, and we're gonna pick up where we left off last time and learn about the Python basics. We need just some aspects in order to automate different steps that we want to take a look at. So we're going to focus on the essential parts that we need to then write our automated programs and automate things such as, for example, reading data from the web using web scraping, and also automatically reading and generating data for Excel, for example, or Google Drive. So let's first of all have a look at expressions in our interactive shell. Let's open up our Mu editor. And to get started, we are just going to type in a very simple expression. So we can type in 2 plus 2 and press enter, and we can see we get the result 4. So it simply calculates the result. So what we typed in here, 2 plus 2, is called an expression in Python. And this is the most basic kind of programming instruction that we are going to use in Python. And expressions consist of values, in this case 2 and 2, and operators, in this case the plus operator. And they can always evaluate down to a single value. And that means we can use expressions anywhere in Python code where we can use a value. But we don't even have to have an operator as we have up here. We can also just enter a value, for example 2, and press enter. And this is also a very simple expression. Now there are a number of different math operators available to us. So if we head over and we have a look at the book again, we can see a list of the math operators available to us, and they have a certain order of precedence. So for example, we can work with exponents. So for example, 2 to the power of 3. We can use the modulo or remainder operator, more on that later. We can also perform integer division, also called float quotient. And then of course the regular ones like division, multiplication, subtraction, and addition. Now these operators are performed in a certain order. So for example, if we head back to our editor here, and a little tip, if we hold down our control key and press L, we basically clear the screen. And now if we type in an expression, for example 2 plus 3 times 6, then the order of precedence will be taken into effect. That means if we take a look at the two operators, plus and multiply, we can head over to the table and have a look, and we can see that addition here is at the very bottom of the table, so it will be executed last. We can see that multiplication is on top of the plus operator. That means this will be executed before addition. So if we have a look, that means we are first going to multiply 3 by 6, and then we are going to add 2. So basically the same approach we would take in regular math. So here 3 times 6 is 18, plus 2 is 20, and that's exactly the expression that we get. Of course, we can change the order of precedence, and one way to do that is to use parentheses. So if we have a look at the same expression again, a little hint, we can just press the up arrow on our keyboard, and this is going to show the previous expression that we executed. We can now wrap 2 plus 3 in parentheses, and now parentheses have a higher precedence than multiplication. That means we are first of all going to add 2 and 3, which is 5, and then multiply that by 6, so we should get back 30. And that's exactly the expression we get here. We of course can also perform operations on very large numbers, and the big advantage is that of course the computer can calculate it almost instantly, so we get the results very quickly. Let's have a look at some other expressions. We saw that in our list, the highest order of precedence was a power operator here. So for example, we can have a look and see what 2 to the power of 8 is, which is 256. We can also perform regular division, like this. And we can also perform floor division. In this case, we are going to use 2 slash symbols here. And this is basically going to perform that division and then basically throw away everything after the dot. So that means in this case we just get back 3. There's also this modulo operator that may be unfamiliar from math operations. What this basically does is it shows us the remainder of performing an operation. That means if we type in 23 modulo 7, we get back 2 because we divide whatever is divisible by 7. So for example, in this case here, 21 would be evenly divisible by 7, which is 3. And then we have a remainder, so 23 minus the 21 that we could evenly divide by 7 is 2. So this is a remainder that's left over. And that can be very useful in certain programs. And we can also have, of course, a look at a little bit more complicated expressions like this one here. So here we have 2 main expressions here, 5 minus 1 in parentheses, and then we have double parentheses basically, and inside of that we have 7 plus 1, which is going to be executed first, then 3 minus 1, which is executed, and then we have basically the outer parentheses, so we're going to calculate that and then multiply it with the result of 5 minus 1. And if we do that, we get back 16.0. Now when we perform these operations, and especially mathematical operations, sometimes it may happen that we mistype something and then we get an error that's notifying us. So for example, let's say we have an invalid expression. Let's for example type in 5, our value, then plus our operator, but we don't add a second operator. And when we press enter, we can see that we have a syntax error here because this is not a valid expression. It expects actually a second value to be added here, which we didn't do, so therefore we get back syntax error that we have an invalid syntax. And as another example, if for example we have a number of different values but we add 2 operators in between 2 values, that's also invalid. So in this case as well, we will see that's an invalid syntax, and we can always see this little character here that shows us basically where that error occurs, so we can make the appropriate adjustment. Now in Python there's something called data types, which basically determine what kind of values we are working with. So let's head over to the book and let's have a look at different data types. And the ones we are going to look at first of all are those 3 here. Integers, which are whole numbers that can either be positive or negative, for example -2, 0 or 5. Floating point numbers, which are basically decimal numbers, which have a dot separator here, so for example -1.25, or also for example 1.0. And we have strings that we learned about last time briefly in the previous video. So here we can see these are basically words or text, and they are always shown in quotation marks, either in single quotes or in double quotes. Now especially when we work with strings, there are some errors to take note of. So if we head back over to our code editor here, we can for example type in a string by again adding those quotation marks, and if we don't actually add a quotation mark at the end, so we would here, if we leave that off and we press enter, we are actually going to get a syntax error here. So it says EOL, which stands for end of line, while scanning the string literal, so that basically means it's missing the final quotation mark here, so it isn't properly ended, and therefore this would be an invalid syntax. We can also use math operations on our strings and basically concatenate them, meaning adding them together. So let's say for example we have 2 names, let's say Alice and Bob. Those of course are strings because they have those quotation marks around their names, and we can add them together with a plus operator here. So if we press enter, we can see those 2 strings here have just been added together, and therefore they basically form a new string that is being created. But what we can't do is we cannot add different types together. For example, if we try to combine the string data type with the integer data type, that's invalid because Python doesn't really know how to handle this. So in this case here we are going to get a type error. It tells us that we can only concatenate strings, that's what str stands for, and not integer values to string values. We are going to learn later on how we can turn integer values into string values, or also how we can turn at least some string values into integer values to work or to perform mathematical operations on them. We can also perform some other operations on our strings. So for example, we could multiply them. So in this case here, if we multiply Alice times 3, we actually get back Alice 3 times, and that's all concatenated together. But here, of course, it wouldn't make any sense if we try to multiply two strings together. So if we try to do this, that's really unclear what should happen. Therefore, again, we are going to get a type error here, and we can't multiply a sequence of string values, non-integer values together. So in this case, we really need to multiply this with a number in order to actually get something useful. Now, when we work with the same values over and over again, it makes sense to actually store them so we can very easily access them. And in Python, there's something called a variable, which is basically a container that holds a certain value. So in order to work with that, we can first of all define our variable, for example spam, and then we assign a value to it. So we just add the equals operator and then the value, for example 42, and now the value 42 is assigned to this variable. So if we type in the name of the variable again and press enter, we can see that we get back the value that's stored inside of that variable. Let's do the same for another variable. And now we have spam and x, and we can go ahead and basically perform the same operations as we did before on the values, but instead of performing them directly on the values, we can perform that on the variables holding those values. So we can, for example, say spam plus x, and that's gonna get us back 44 because spam holds the value of 42 and x holds the value of 2, so we add those two together and we get back the value of 44. And we can even go so far as to reuse the same variable name multiple times. So here we are taking the value of 42 that's stored inside of spam, we're adding the value of 2 that's stored inside of x, and then we are again taking the value of spam, which is 42, and now we get back 86 as a total value here. And we can even override existing variables. So as an example, we can say we want to store a new value in our spam variable, and we are actually going to use the existing spam value, which was 42, and we are going to add a value of 2 to it. So now we're basically saying 42 plus 2, which is 44, and we store that back in our spam value, so we're basically overriding it, if you will. And now if you have a look at spam, we can see that indeed has been changed to 44. And of course we can do the same for string values. So here we can, for example, say we take the string hello, which is now stored in this variable and can be printed out. And then we could also change it to a different value and print that out. Now when we create those variable names, such as spam for example, there are certain rules that we need to keep in mind. There are certain names that are invalid and cannot be used for a variable name. There's a handy overview again here linked in the book itself. So here are some examples of valid variable names. For example, current_balance is a valid variable name, but if instead of using an underscore we use a hyphen here, current_balance, that is not allowed because hyphens are not allowed inside of variable names. We can also, for example, mix lowercase and uppercase letters, but we cannot use space characters inside of our variable name. We can also use numbers at the end or inside of our variable name, but not at the beginning because variable names are not allowed to begin with a number. It's also possible to use an underscore at the beginning of a name, underscore 42, but we cannot use a number because again it can't begin with a number. And by the way, this is a valid name here for a variable, but it's not very clear, so in general we should aim to have variable names that are expressive, that clearly label what's actually being used in the variable. We can also use total sum for example, but if we try to replace the s for example here with a $sign, that's not allowed because special characters cannot be used inside of variable names. And finally, we actually need to use a variable name and not a string. So if we use quotation signs here, it's unclear to Python what we actually want to accomplish. Python basically, or the Python interpreter basically thinks that this is a string we are looking at, but therefore we need to basically use that without quotation marks. And a quick note, variable names are case sensitive. That means it really matters if we use, for example, all lowercase letters or all uppercase letters. Those would be different variable names. Now, so far we've been working in this REPL environment here, and that's really handy to have a quick look at very simple Python parts, Python syntax. Now let's have a look at a larger program, and for that we are actually going to write that in the upper part here of our editor. So up here we can enter a program. Let's write it out first, and then we are going to have a look at it line by line to see what it actually does. So once we typed out our program here, we need to save it. Actually, if we click on run, we are automatically going to be asked to save it under a name. So we can basically provide any name that should end in .py, which is showing us that it's basically a Python file. So here we're going to call it hello.py and click on save. And now that we clicked on run, it is running our program here on the right side. Let's actually resize it a little bit. We can actually also hide our REPL environment. So here it's running our program and it says, hello world, what is your name? We can type in a name and press enter. Now it says it's good to meet you, and then the name. The length of your name is, and it shows me it's 5 characters long, which is correct. What is your age? I'm just gonna put in a fictitious number. And then it says you will be 5 in a year. We could also close our code editor and then later on simply click on load to actually load our program and run it again, which makes sense if we have a lot of different programs that we want to execute at a later stage. Now let's have a look at what actually happens in our program and how this basically works. So first of all, the first line here is a comment. Whenever we start something with this hash symbol, it's actually not interpreted as code. So Python basically ignores it and doesn't execute it. And the comment is basically just for us as programmers who are writing this code, or for other programmers who may want to have a look at the code and make some modifications later on. So this is just some instruction for us, and it basically tells us what the program does. So it says hello and asks us for our name. We can add these comments at the very beginning in their own line, or we can also add them to an existing code line as we do over here or down here. These are also comments, so you can always see when we add those hash symbols and then write some text after that, it's displayed in gray, meaning it's not actually code that's executed. Now after that we have this next line, print, and then in parentheses what's being printed out. Print is a standard, what's called a function in Python that basically does a certain thing. So print, for example, prints out a certain string here, certain value to our console down here. And so we can see we are printing out hello world, and then after that we are printing out what is your name, so the first question we saw in the beginning. And we are going to learn about functions in more detail and also write our own functions at a later chapter. After that we see the first variable of our program here, so my name, and we see the equal sign, so after that comes the value that's being assigned to this variable. And here we have another function called input, and the input function basically gets some input from the user who is executing the program, so whatever is being typed in here is then stored in the variable. And since we are asking the user for the name before, the user can type in the name and the name will be stored in the myname variable. After that we have another print statement here, and this time we are printing out a string, so it is good to meet you. And then we use the plus operator that we learned about before to add another string to it. In this case we use the variable myname that holds our name, and that's being added to the program. So we can see this is this line here. In this case I typed in my name, and that was added in here, and it was accomplished by using this variable. And then after that we have another print statement, the length of the name is. And then we have another print statement here where we use another function called len. And len is also a built-in function in Python that's returning the length of a variable. So in this case here it has a look at this particular string, and it sees that it's 5 characters long, and therefore it prints back the value of 5. Then again, we ask the user for the name using the print statement, and we basically do something very similar to up here, where we are using a variable to store something that the user puts in. In this case, the user would not put in a string as before, but instead an integer value, which is then stored in my name. And then finally we print out you will be, we use the plus sign, and now we see something new. We use first of all int, which is a way of basically changing the input that's entered into an integer, because whatever is entered into the input will first of all be a string. That's just how the input function works. By typing in int, we are turning that into an integer, and then we can add 1 to it. Of course, it would throw an error if we tried to add 1 to a string, so therefore we need to turn it into an integer. We add 1 to it, so in our case here we have entered an age of 4. We add 1 to it, so we get back 5, and then we turn that back into a string by using that str here, so we can properly print it out afterwards. Then we have another plus sign, which basically concatenates that string here to the next string in a year, and therefore we get back you will be 5 in a year. So there's quite a lot of things happening at the same time, but it's all elements we have seen before, so feel free to just have a look at it line by line to make sure that you understand everything that's going on here. And let's have a quick look at some of the functions we've seen so far. If we open our REPL again, we can have another look at that. So here, for example, we can see we can type in len and a string, which we saw before, but we can of course do the same for some other string and even an empty string, which will give us back a value of 0. Or we can type in an entire sentence, and this is going to give us the entire length, including the white spaces of the string that we typed in here. And then concerning the string function that we saw before, if we go ahead and we type in string of a value here, so in this case an integer, we can see that's now being turned into a string. We can see that because there are these quotation marks around the number. We can do the same for example, a floating point number. So if we add a decimal point and some values behind that, we can see that's also turned into a string. And the opposite is also possible. So if we, for example, want to turn the string 29 back into an integer, we can do that. But of course, if there is some string entered that cannot be logically turned into a number like this one here, we are actually going to get a value error. So we always have to take a look at that and make sure that we can actually convert a string, that it makes sense to convert that into an integer or into, for example, a floating point value. And it's important to note that even though we can turn a number into an integer, for example, or vice versa, those are not the same. So if we type in, for example, 42, we can enter the double equals operator and then add a number, for example. So this is checking if the string 42 is equal to the number 42, and here we get back false because that's not identical. But if you have a look at a string and an integer or floating point number, those of course would be different values. Now let's finally have a look at some practice exercises. If we head back to the book here, we can see there are a number of different questions we can answer. The first one is, which one of the following is an operator and which ones are values? So first of all, we have the asterisk symbol here, so the multiplication. That of course is an operator. This is a value here, our string. This would also be a value. Then we have the minus, divides, and plus operator. And finally, we have a value of 5. If you take a look at which of the following is a variable and which is a string, again, if we think back, we know when a variable is actually valid. It cannot start with quotation marks, so that would be an invalid variable. The quotation marks always show us that it's a string, so therefore this would be a string, and the one here would be a variable. Now, we should name 3 data types. We learned about 3 different data types. We learned about integers, which are whole numbers, either positive or negative. We learned about floating point numbers, which are basically decimal numbers with a decimal point. Again, they can be positive or negative. and we learned about string values, which are basically ways to represent text. Now we also learned about expressions, and we learned that expressions are made up of values and operators. So for example, 5 would be a value, plus would be an operator, and 5 again would be a value. So we could have the expression 5 plus 5, and that would of course give us back the value of 10. And expressions can be really useful to perform, for example, some computations, or for example to build up larger expressions made of smaller expressions. We saw that when we chained together different mathematical operations. We also learned about assignment statements. For example, we assigned the variable spam, or rather we assigned the value of 10 to the variable spam. The question is, what is the difference between an expression and a statement? So the main difference is basically that a statement, or the assignment statements that we learned about, has like an equal sign in it, so therefore we do some assignment, and the expression would basically be what we've seen so far, a calculation that we perform, so it would have a value and an operator. So next, what does the variable bacon contain after the following code run? So we assign the value of 20 to it, and then we add +1 to it, so therefore we are using these variables here to do some changes to it. We basically don't reassign the value of bacon, so therefore bacon would still have the value of 20. If instead we wrote bacon is equal to bacon plus 1, then we would have changed the value of bacon. And just to make that a little bit more clear, we can head over to our code editor. And if we take that example, so we have the value of bacon, and then we add +1 to it, we can now write bacon again, and it still has a value of 20. If we want to change that, we would have to write bacon equals bacon +1, and now if we run it, then we get back a value of 21. So in this case, we need to make sure that we actually have a statement, an assignment statement, in order to actually change the value. Next, we'll just the following two expressions evaluate to. So we have spam plus spam, so that is a concatenation, of course, so we would have spam 3 times. And this one is basically the same output here, so we have spam and we multiply this with 3, so we have spam, same outcome basically as up here. So why is x a valid variable name while 100 is invalid? If we think back about the rules, we can't have a variable name that starts with a number, so therefore 100 is invalid, but it can of course start with letters, for example x. There's no white space in there, there's also no special character in there, so therefore x is a valid variable name. What 3 functions can we use to get the integer, floating point, or string version of a value? So the functions we learned about, this is actually called casting, is int to get or to turn a string value, for example, into an integer. We have learned about float, which turns a value into a floating point number, and then str for string to turn a value into a string. So just to recap, if we have a look, for example, at this, we can have, for example, a string of 12 and turn that into an integer value. We can use 12.34, for example, and turn that into a floating point number. And of course, we can do the reverse, so we could go ahead and turn, let's say, the number 12.4 into a string. So these are the 3 ways we can basically change the data type, which is called casting. So the last one here, why does this expression cause an error and how we can fix it? So we have here a string, then an integer, and then another string, and those cannot be added together. Let's actually copy this over into our code editor to have a look at that. If we run that, we see we get a type error because we can only concatenate string values but not integer values. So to fix that, what we can do is we can turn that into a string value by simply typing str and wrapping our number here 99 inside of str. So now when we run the code, we actually print out I have eaten 99 burritos. So we always need to make sure that when we use concatenation, those are the same data types, those are all strings, otherwise it's not gonna work. And then for extra credit here, we can search online for the Python documentation for the length function that we saw before, and it's part of the built-in functions. So here we can also have a look at other functions that Python has, for example at the round function, and then experiment with that in the interactive shell. For that, it's always good to just start a Google search and, for example, search for Python lang function. One of the results that will be coming up is the official Python documentation, docs.python.org. And here we can see a number of built-in functions that automatically come with Python. And here we will find the lang function, which we can see here. If we click on that, we can see more information. So in this case here, a short explanation. The lang function here returns the length, the number of items of an object, and the argument baby sequence, such as string, bytes, tuple, etc. that we didn't learn about yet, or a collection. So basically what we have been using so far to get the length of, for example, a string. Now if we switch back, we can see a number of additional built-in functions, and one of the ones available to us is the round function here. If we click on that, we can see that the round function returns a number rounded to a certain number of digits that we can specify in the function after the decimal point. And if we don't provide a value, so if we just type in a number after that, then it returns the nearest integer to the input. So to make that a little bit more clear, let's head back to our code editor here. Let me just make this a little bit larger. And we can go ahead and we type in round and then a number, for example 34.567. And if we press enter, this number should now be rounded to the next integer. So if we have a look, we have 0.5 after the decimal point, so that should be rounded to the integer 35. And indeed we can see it has been rounded to that number. Now if you want to have a different precision for the number, we can add a second value here, separated by a comma. So for example, we could say that we want to have 2 digits after the decimal point, and if we press enter here, we can see now it's rounding actually not to the nearest integer here as it did up here, but instead we get the nearest value after 2 decimal points. So here this would be the second number after the decimal point, and since the next number after that is a 7, it will be rounded up to 57, which is exactly the result we get here. So we covered quite a few basic concepts in Python. We learned about expressions and how to work with that. We learned about 3 different data types: integer, floats, and strings. And we also wrote our first program and actually ran it inside of our code editor. In the next video, we are going to build on top of that and learn about flow control, how we actually can make decisions running Python programs. So see you guys in the next video.